This is an app that we've created called the Foos. Has anyone seen this before? I feel like I've shown it to half of you just in the last day or two.
Show it again.
So these are some levels we released last year as part of Our Code, which is a big nonprofit organization to get 100 million kids just learning 1 hour of computer science. We are a words-free approach for 2 reasons. One is that we go as young as 5-year-olds, and so there's a lot of pre-readers and kids that maybe can't read quite well yet, and we're able to go international on day 1. Part of our mission is to democratize the subject of computer science, get it out to kids, especially underprivileged kids who maybe don't have the role models and don't have the facilities and the scaffolding to really understand that this is a fun subject, this is a creative subject. I love computer science. This is sort of my way of sharing my love of computer science with kids all over the world. So you'll notice we're not teaching a language. There's no syntax. There's no mouse and keyboard. We find that if we get those things, those artificial barriers out of the way, kids as young as 5, 6, 7, 8 years old can learn some really important concepts. Our goal is not to turn a bunch of kids into computer scientists, but rather to teach them the basics of sequencing, problem solving, how to abstract a problem, how to break it into small chunks. Really important life skills, executive function skills. You'll notice that we start out the game very, very slowly, very, very simply. Every time we go to play test with kids, which is about every week, we find out that between any 2 levels, there turns out to be another level of scaffolding between them to just very gently ramp up the difficulty. Our goal is to get kids excited about the subject and to build confidence in the subject. If you look at how we teach English and math, we spend 12 years of starting in kindergarten with singing songs about letters and numbers and turning the letters and numbers into fun characters. But we don't do that with difficult subjects like computer science and a lot of the STEM fields. Let me jump forward a little bit because I want to get to some of the fun stuff. So we get into advanced things like looping, like conditionals, parallel programming. This is our construction character, and I'm going to drag in a loop block, and he's going to build some crates. And if I put a command on a loop, he cranks out these crates really fast. It takes less space in my programming bar. And his goal is to get his tools back. The glitch, which is our little loop character, has lost his tools. And here we find that kids will often put a jump command in and hit the button again to make him play again. But oh, he's building more crates. Why is he doing that? And this is a very teachable moment where kids learn that computers are not smart. They're just really good at following directions and doing that really quickly. And it's up to you, the computer programmer, to teach the computer what to do. So all of that was available last year. This year for Our Code, we're coming out with Foos Studio, which is a really exciting place. I grew up with Logo in the 80s. Michael and I were talking about this. Where I didn't know I was programming a computer. I thought I was creating artwork, through code. So we want to give kids a creative space where they can use these programming concepts that we've introduced in these puzzles to make their own video games. So here I have a traditional level editor, and I can drag in some spikes and things, and maybe some coins, and hit the play button up here. And now I'm actually playing a sort of Mario-style game, and I'll try to play with one hand, and get the star. And that's kind of cool, kids love this, but that's not good enough. So what we want to do is actually let kids go under the hood and program these interactions. So I can tap on the spikes and actually see the code, and this is using the same coding interface that we've introduced through these puzzle chapters. And this says when the player bumps into the spikes, they're going to hurt them. But I can take that out and say, no, I want my spikes to actually jump when I bump into them. And so now when I bump into them, they jump. And that's kind of silly and fun, but that's what 6-year-olds like to do. I can take actually anything in the level and say, when I hit the start button, I'm going to make these blocks jump. And so now it's this kind of fun game where the blocks have sort of come alive and I have to jump on them. But all the physics still work. And then just the very last thing, I can take this game and publish it to the world. So we're creating an entire kids community of coding around the world and curating their creations. They can share them with their families, their friends, their classmates. Cool, that's it.
Come on up here.
Yep.
What's the name of the company again?
CodeSpark.
The name of the company is CodeSpark. We're trying to spark just the first bit of interest in coding. And the name of the game is called the Foos.
Say the name slowly.
Joe. Foos, F-O-O-S.
F-O-O-S.
Yeah, so foo and bar are sort of, going back to MIT, I think, temporary variables. So if I want to say, well, X equals 12. In computer programming, a lot of programmers say, well, foo equals 12, and bar equals 13, and then they write an algorithm based on foo and bar. And so that's where the name comes from. But it's also just kind of a silly, fun word that's easy to say and easy to spell.
Foo! Everybody say it.
And very international.
Yes.
So that was great. For the second product that you demoed, once they publish to the community, can another child download and modify?
Yes, absolutely. We've seen that's something that works well with the Scratch community. So they can remix any level, change the way it works, and more importantly, see what another kid did and understand their code and be inspired by that. And then take that piece, almost like a professional software engineer would do with like an API, the Facebook API.
And I think it's really, really cool. I was wondering if you had done any research about whether kids, or at what age kids, start to be systematic as opposed to trial and error. Because I remember in the logo research, they found that even as late as 4th and 5th grade, kids were basically doing trial and error on long sequences and weren't really using stuff like that.
Yeah, it's a great question. We haven't done a lot of that research ourselves, but we read a lot of it. Marina Burrs does a lot of research on that. Of course, Seymour Papert and MIT. I think that the trial and error process is an interesting and important process, especially in STEM fields. What we see, the reason we give out the 3 stars is because a lot of kids will use trial and error and kind of muddle through it and maybe get 1 or 2 stars. We only give the 3 stars if you write sort of the most elegant and perfect program. So there's a lot of replay value there, but the replay value is actually encouraging a deeper understanding as well.
How do you explain that to kids? How do you explain what gets you 3 stars to kids?
The game is meant to be very self-directed. Kids seem to be able to figure this stuff out just naturally, these digital natives. Adults want instructions. And we have to resist that urge to put instructions in the game. What we do is we have a PDF, a solutions guide, a curriculum for teachers. So if they want to facilitate that
I'm going to show you the instructions with adults. Take out your lasers.
Yeah, please.
And you want just Duster Magic, or you want to frame it?
Duster Magic's
All
great.
right, Duster Magic. Today's a good day for
A happy
lasers.
crowd this morning.
That's right, good job.
Thank you.
Well done.